Lesson 6-1, Triangle Segment Vocabulary and Theorems. The main purpose of this lesson is to understand the vocabulary that we're going to be working with the next day in class. The first term is midsegment. A midsegment is of a triangle joins the midpoints of two sides of the triangle. So in this case, B is the midpoint of AC and D is the midpoint of CE. Make sure that you're making the notes onto your unit guide. The midsegment theorem tells us that the midsegment of a triangle is parallel to and equal to half the length of the side opposite of it. In our diagram, that would make BD parallel to AE. So let's go ahead and mark that. And we would then know that BD is half the length of AE. Now let's move on to perpendicular bisectors. We already know what a perpendicular bisector is. It's a segment that is both perpendicular to a side and bisected. So this segment right here would be perpendicular to the side AD and would bisect that side so that those two segments would be congruent. The same would hold true of the other two perpendicular bisectors. This one would be perpendicular to AE and bisect it. And then our third one would be perpendicular to the side DE and bisect that side. Now let's look at some special properties of the perpendicular bisector. The perpendicular bisector theorem tells us that a point is on the perpendicular bisector of a segment if and only if it is equidistant to the endpoints of the bisected segment. Remember, if and only if means it has to be true in both directions. So in our situation, we know that this point right here is on the perpendicular bisector because this segment is congruent to this segment as they join the ends of the segment that it is bisecting. The second special property is concerning our point of concurrency. The point of concurrency is a point that is the intersection of the three segments in our situation. In this case, these are perpendicular bisectors. We're going to be looking at points of concurrency of different types of segments. But in this case, the point of concurrency for our perpendicular bisector is called the circumcenter of the triangle. All of the points of concurrency of these segments we're going to be looking at today have similar names. So you're going to have to work hard at making sure that you understand the difference between them. The circumcenter of a triangle is the center of a circle that would pass through the vertices only of the triangle. This triangle would be said to be circumscribed by the circle. Or we can turn that around and say that the circle circumscribes the triangle. Circum meaning around, that can help you remember what's happening here. The circumcenter can be inside, outside, or on the circle itself. In the first situation, our circumcenter falls inside the triangle. This is an acute triangle. That's when this would happen. For our second situation, our circumcenter is falling right here. So that is outside of our triangle. The triangle that we're looking at now is an obtuse triangle. And our last situation is where the circumcenter is falling on one of the sides of the triangle. This particular triangle would be a right triangle when it falls on the triangle. The last special property concerning our perpendicular bisectors is that the circumcenter is equidistant to the vertices of your triangle. So from my circumcenter, the distance to each vertex would be exactly the same. Now let's move on and talk about angle bisectors. Again, from the name, you know what an angle bisector is. It's a segment that bisects an angle. So our angle bisector theorem tells us that if a point lies on an angle bisector, then it is equidistant from the two sides of the angle. If you look at the picture below, they're showing this a little bit more clearly. Here's the angle that's been bisected. Here's the point falling on the angle bisector. We know it's an angle bisector because the two angles are marked to be congruent. What this theorem tells us is that the distance from the angle bisector to the sides of that angle would be congruent. The converse of this would also be true. If a point is equidistant from the two sides of an angle, then it has to lie on the angle bisector. This can be particularly helpful in improving congruent angles. The angle bisectors do also have a point of concurrency. They're concurrent at a point called the incenter of your triangle. Okay, so remember the last one was the circumcenter, this is the incenter. The incenter of the triangle has to be equidistant from each side. So this point, if I measure the distance to each side, each of those distances would be the same. The incenter is the center of the circle that touches the sides of the triangle only one time. This circle would be inscribed in the triangle. Okay, remember, circum, around, in would be inside. The incenter, because of that, would always fall inside the triangle, no matter what. Now let's move on to the median. The median of a triangle joins the vertex to the midpoint of the opposite side. The point of concurrency for your medians is called the centroid for your circle. Interesting thing about your centroid is this is your balance point. If you try to balance the triangle, this is where the only point that would work for this. Your centroid is 2/3 of the way along any one of the medians. This can be a little confusing because we're dealing with fractions, but if you realize this, all this is saying is that the length, if we're looking at this median right here, the length of AG, which is our longer one, would be 2/3 of the length of AE, or GE would be 1/3 the length of AE. Sometimes it's easier to think of that as the longer segment being twice the length of the shorter segment. The longer segment is going to be the one that has an endpoint at the vertex of your triangle. Your shorter segment is going to have an endpoint on the side of the triangle. So if we consider the median AE, the longer segment would be AG. The endpoints of your longer segment will always be the centroid and the vertex. Your shorter segment, GE, would have endpoints of the centroid and the midpoint of the opposite side. Now let's look at our final one, and that is the altitude. The altitude is the segment that starts at a vertex and goes perpendicular to the opposite side. This is often this is the height of your triangle. Let's look at the properties of our altitudes. The altitude's point of concurrency is called the orthocenter of our triangle. So keep in mind we have a circumcenter, an incenter, a centroid, and an orthocenter. You need to find a way to know which point of concurrency goes with which segment. The orthocenter can also lie inside, on, or outside the triangle, similar to the circumcenter. When you have an acute triangle, this is when your orthocenter is going to lie inside your triangle. For a right triangle, your orthocenter is going to lie on the triangle, and for our obtuse triangle, your orthocenter is going to be outside of the triangle. We're going to stop our notes here and finish these in-class examples tomorrow when we're all together. Now go ahead and finish your online work for this section.